Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to inverse relationship functions. I want to point out before we start that inverse relations is more open than inverse functions. So in order for you to have functions, again, it must pass the vertical line test, where relations are any equation at all. So let's look at f of x equals x cubed. And f of x equals the third root of x. And I'm going to graph these on the same plane. So please bear with me. Okay, so it doesn't matter which one of these I substitute into. If I substitute 0 for x cubed, I get 0. 1 cubed is 1. 2 cubed is 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 cubed is negative 1. And negative 2 cubed is 1, 2, 3, 4, 5, 6, 7, 8. And if you look at 1/2 cubed, you get 1/8. So there's kind of a little bit of a curvature going here, curving up. And this has kind of got that concave down kind of thing. And I'm freehanding, so please keep that in mind, that I am not as perfect as maybe a computer drawing might be. Okay, so now let's look at f of x, where it's the third root of x, and this one I'm going to do in orange. If I substitute 0, I still get out 0. If I substitute 1, I still get out 1. If I substitute negative 1, I still get out negative 1. But if I substitute 8, so 1, 2, 3, 4, 5, 6, 7, 8, I get out 2. And negative 8, I get out negative 2. Okay, so you might have noticed this is the ordered pair 8, 2, and this is 2, 8. And it's because this takes you to the third power and this reverses that process. I guess I should have called this G. Okay, so these happen to be inverse functions. One of the reasons why I know they're inverse functions is if I do the composition of functions and I do f of g, or I do g of f, it doesn't matter. Both times I'm going to get x, because think about this. Put 8 into here, you get out 2. Put 2 into here, you go back out to 8. They undo each other. One does the math, one undoes the math. It's like, you know, walk 4 steps forward and 2 steps right. Now go 2 steps left and 4 steps back. You wind back at the same spot you started because I had you do the exact opposite. Graphically, we can see these are inverses because they fold over a line of reflection, y equals x. Which just happens to be that, right? So we denote inverse. If this is our original function, then we denote the inverse by using a negative 1. Okay, so if they're inverses and we do the composition, we should get x. So f of f inverse will always go to x. Now, I've put this on a test question many times, and I've said, hey, find f of f inverse of 9. And I've made f a really complicated equation. And I've seen students really trying hard to figure it out. This one does the math. This one undoes the math. Okay? So if this one does the math and this one undoes the math, then you're going to wind back up at your starting point, which was 9. Because you're starting with 9, you're doing a bunch of math to it. Then you're undoing all that math, so you're back at 9. So these kind of cancel each other out. Okay, so I want to draw an inverse relationship based off of a picture. So I'm just going to give us a picture. We're going to draw the relationship. All right. All right, I have a quadratic graph here. And this is going to be f of x. And we are going to draw the inverse relationship without doing any algebra. Okay? So, if you see here, this is left 1, 1, 2, 3, 4, 5. So instead of going -1, -5, we're going to switch that. We're going to do -5, -1. Okay? Instead of 0, -4, we're going to do -4, 0. Instead of 1, -1, we're going to go -1, 1. Instead of -2, -4, we're going to go -4, -2. And instead of -3, -1, we're going to go -1, -3. Whoops, I missed my line. There we go. Okay, so do they fold along y equals x? Absolutely, yes. However, many books are not going to want to have you do this because, I'll call this one f. Is f a function? F is a function because it passes the vertical line test. I'll call this one g. Is g a function? No. It fails the vertical line test. Okay? So, new vocab word coming in. F is not 1-to-1. Okay? Let's come up here. Is f a function? This one's a function. Is g a function? Yes, this is also a function. So, f, in this case, is 1-to-1. Okay, so how could I tell if I had a 1-to-1 equation by just looking at the original? Think about this one. The green line is 1-to-1. The orange line is not 1-to-1. So how do I know the difference? Okay. A 1-to-1 function function indicates that it passes the vertical line test. And to finish out that 1-to-1, passes the horizontal line test. The horizontal line test is similar to the vertical line test. It's just instead of vertical, it's horizontal. So when I drew that parabola, it failed the horizontal line test, which tells me the inverse is not a function. Because, come back to this horizontal line, when you reflect it, became this vertical line. That's why if the orange fails the horizontal, the green will fail the vertical. Because everyone's getting reflected, right? A horizontal line reflected becomes a vertical line. So what can we do? If I'm in a textbook that wants me to only deal with inverse functions, what can I do? Well, in order to bring this to 1-to-1, I just need to limit my domain. I need to say, hey, look, I'm not going to use the entire parabola. I'm going to use the parabola starting at x is -1. For x is greater than or equal to -1. Which then means when I reflect it, I'm only using this part. And now, this is for x is greater than or equal to 1, 2, 3, 4, -5. So we only use half the parabola, and now we've created a restriction so that where before it was not an invertible function, and now it is an invertible function because we just got rid of half the picture. Now, why -1 and -5? Well, in this ordered pair, it's -1, -5, right? This ordered pair flips, -5, -1. In fact, if I use this, f would have a domain of x is greater than or equal to -1 and a range of y is greater than or equal to -5. Whereas g would have a restricted domain of x is greater than or equal to -5 and the range of y is greater than or equal to -1. Why is that? Well, in order to do this, we flip-flopped our ordered pairs. So when you flip-flop your ordered pairs, you also flip-flop your domain and range. So keep that in mind. But the reflection must be perfect, okay? Whatever your starting image is, your ending image has to be a perfect reflection, and you have to restrict your domain accordingly. Okay, so graphically, we can see it, we can do it. So let's find the inverse. F of x equals 2 minus the third root of x plus 1. Okay, first of all, this is a third root graph. If you watched my third root graph videos, you would know that I talked about them being the walk like an Egyptian graph. And they pass the vertical line test, and they also pass the horizontal line test, because this is still continuing to climb, just not very quickly. So this is 1-to-1. So the inverse is a function. Okay, I find at this level a lot of students get confused with f of x, so I'm going to rewrite this problem. Y equals 2 minus the third root of x plus 1. Now, I need to find the inverse equation, not the inverse graph. I could graph it and then find the inverse. I don't want to do that. I want to find the actual inverse equation. So the first thing I'm going to do, just like I did on the graph, is I'm going to flip-flop my x's and y's. So x equals 2 minus the third root of x plus 1. I'm going to work, or sorry, y. Now I'm going to work to get my y value by itself. So I need to get rid of the, actually I'm going to add this to the right and subtract the 2x over. So the third root, that made the y part positive. Okay, raise everything to the third power. I'm not actually going to multiply it out, that's okay. And then I'm going to subtract 1. And then I'm going to use my special notation because it really wasn't x and y, it was really x and f of x. So f inverse So if you were to graph the green and the purple on the same equation, or on the same graph, then they would be perfect reflections over the line y equals x. Let's try another one of those. Okay, is this 1-to-1? Is it fully, is the function an invertible function? Okay, so it makes a parabola. So it passes a vertical line test, but it fails the horizontally. So no, the inverse is not a function. As f of x is not 1 to 1. How can we fix that? Well, we can limit the domain. Okay? We can limit the domain by using half the parabola. So we would need to know where the axis of symmetry is. Okay, so if you remember, the axis of symmetry is at negative b over 2a, which in our case is negative 8 over 2 times 1, which is at negative 4. And the vertex is at negative 4, 0, if you utilize an ordered pair. Okay, so I want to go just this part and over. So right now, my domain is x is between negative 4 and infinity, and my range is between 0 and infinity, because I'm using the vertex to the right and up. Could I have picked the other side? Absolutely. And I'll get to that here in a second on how you could have picked the other side. All right. So now we've limited our domain. And I'm going to go ahead and make this even easier on us. I'm going to write it in factored form. Ah, that is much easier on us. And I'm going to call that y instead of x. So now I'm going to use the inverse. X equals y plus 4. And I got to get the y by itself. First thing I'm going to do is plus or minus the square root. Ah. And then minus 4. And I'll go back to that notation. So here's the deal is, we're wanting to just use negative 4. So we're wanting to pick this so that it folds. So is this the positive square root of x version, or is this a negative square root of x version? Since it's going up and to the right, it has not been reflected from the basic. It's just been moved down. Kind of like the original had just been moved left. So we're going to use the positive square root. The negative square root would have gone down like this. That would have matched had we used the other part of the domain. Okay, and so our proper inverse is going to be square root of x minus 4. And our domain is 0 to infinity, while our range is negative 4 to infinity. Because we switched the x and y, the domain and range also switch. Okay? Is f of x equal 2x plus 1 the inverse of g of x equaling negative 1/2 x minus 1? Yes or no? Okay, well, there's two ways we could do it. We could graph it and see if they perfectly fold. But I know a lot of students are like, oh, graphing again. We could test a couple of ordered pairs, but that's not a guarantee. The only way to guarantee is if we check f of g. Does it equal g of f? Does it equal x? And actually, you only need to check one of them, because if one of them works, they're both going to work. Okay, so 2x plus 1, there's your f equation, and I'm substituting g in, which means I'm doing this one. Okay, so let's distribute. Negative 1/2 times 2 times negative 1/2 is negative 1x. 2 times negative 1 is negative 2 plus 1. I'm getting negative x minus 1. Is that just plain old x? No. They are not inverses. Okay. Let's try one more of those. Okay. Well, let's test f of g. Remember, that's where g gets put into f. So we have the third root of something minus 1, and we're putting x cubed plus 1 in there. Well, order of operations, I really don't need the parentheses, so plus 1 minus 1, that simplifies to just x cubed under the radical. And the third root of x cubed is x. Yay, that was just x. Okay, just a double check. Let's just do g of f. And if you are not familiar with the composition that was in my video on function operations, you can go back and check that one out. This time we're putting f into g. So here's our g equation, x cubed plus 1, and we're doing the third root of x minus 1. So the third root and the third power cancel each other out. We're left with x minus 1 plus 1, which is just x. So it worked both ways. Yes, these are inverses. So anytime you need to check, you can just substitute one into the other. If you have a function that's not one-to-one, you can limit the domain and it will become one-to-one.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.